you have when you're trying to decide whether it's principal, medium, or trace. Okay. So first of all, I need the decantate. I get another clean test tube. Boy, these things cycle off faster and faster. I'm not talking that slowly. Okay. So I'm going to centrifuge. Decant. Sorry. Centrifuge. Okay. To save time, I already know that this black precipitate is really fine. It's going to try to go over. So I'm going to use my pipette to separate them. And I use this to divide my mercury to the lead sample up, so I do have to clean this out. Three small rinsings, that should do it. And here's another test of skillfulness, I guess. There's my clean test tube. And I think it's from my shoulder. My hand is just not recovering as well as it should. So I'm going to type that left hand, which is not my usual working hand. So I type that here. Okay, I don't have any black precipitate. I have a lot of liquid left here. Shoulders getting worse. No black precipitate. Okay, I think I got that. Now the check for completeness, and he doesn't tell you this, is to add more 15 molar ammonia. First you look at your precipitate. That's sort of smeared around because of my shaking here and trying to pipette it out. But I'm pretty sure I didn't get any black contamination over here in the solution. So I add another 4 drops of 15 molar ammonia. He doesn't tell you that. Later in the semester, I'm going to ask you as one of the problems to calculate how many drops of 15 molar ammonia you will need to dissolve all the silver chloride you might get if your unknown had contained a principal of silver chloride, or silver ion. And you got the principal amount of precipitate. And it's a lot more than 4 drops. The reason he says 4 drops, his directions are set up for medium amounts. 4 drops will dissolve a medium amount of silver chloride, but it will not dissolve a principal amount of silver chloride. And once we get to complex ions and the equilibrium of complex ions, we'll do the calculation. I say we'll do the calculation. I'll tell you what the problem is, and you get to do the calculation, or try. Then it's going to be more than 4 drops. What it boils down to. This was a medium, so I really don't need more, but that's how you check. So I'm going to add my 4 drops. I think I'm going to add it. Darn. Yeah, I got my 4 drops in there. I didn't get it on my fingers. Some of you aren't going to start wearing gloves. You should always wear gloves. Yeah, mix it up again. Now it's light and fluffy. I don't have to use the stirring rod to it, so I can just do this finger business. Get my counterbalance. And I'm going to transfer this over. I know it's not going to change the amount of precipitate. It's still going to stay the same. If it changes a lot, or if it changes from a gray to a black color, you know that you dissolve some more silver chloride, and you do it a 3rd time. Oh, this thing vibrates that. I didn't think the bench was that deep. Okay. So basically what I'm going to do is treat this as though the precipitate had changed size it hasn't really changed much, and the color is already nice and black because I did get a good separation. But I'm still going to add this to this. In other words, add the rest of the ammonia here. Try to get some light on the tail. Look at it carefully. No black precipitate in my pipette here. Black precipitate in here. Now to store this, I don't want it to dry out because it changes the apparent size of the precipitate. So I'm going to store it with some more 15 molar ammonia, but I'm not going to, well, I'm going to centrifuge to pack it down because it got all agitated again. But this is just for storage purposes. So it's not really critical. Even the 4 drops here, since I added 4 more drops in, isn't critical. But you always want to have about 1/8 to 1/4 of an inch of liquid above your precipitate so it doesn't give you a magnifying effect to make the precipitate look bigger than it actually is. And I am going to centrifuge this again because this is one of my reference solutions, one of my reference precipitates. And when you just let it settle out, without centrifuging, it settles all over the bottom of the test tube and sort of smears out, and it doesn't give you a good reference because, again, it's hard to estimate the size of your precipitate. Now my precipitate didn't change size, so this would be a black precipitate. It doesn't look gray or anything, so I know there's no contamination in there, and I did get rid of the silver. I'm pretty sure I had. And this is now my reference or confirmatory test for mercury, so that's the 3rd test tube in a row. And now I want to test this for the presence of the silver ion. And I'm going to do it by making silver chloride precipitate. I did the net ion equation. It's still up there on the board. And basically I'm going to add concentrated nitric acid to neutralize it. And notice other things I was doing with my fingers there. I'm not going to hold the test tube and add concentrated nitric acid to this. Now if I miss, it's going to hit my fingers, and one of the things that happens, you do that, you get a famous protein test, you get the xanthoproteic test. It turns the protein in your skin a dark yellow color. It looked like you've been smoking for 45 years. Or my dad died from emphysema. That's the color of his fingers. Okay? So anyhow, for this one I either wear my gloves for sure, or I'm going to use the test tube holder so I'm not anywhere near the nitric acid. And the other thing you'll notice, it's going to bubble and foam because you've got concentrated ammonia in here, a lot of base. You've got concentrated acid, a lot of acid. Acid and base make salt plus water plus heat. See, it's fuming and smoking. It looks like there's a white precipitate, but that's because of the fuming, so you can't be sure until you centrifuge. And some people say, oh, I got a precipitate, and they report it. And then later on, they look, after I marked it wrong, and there's no precipitate. By the same token, if you don't get any precipitate, you want to add more nitric acid because maybe you didn't neutralize the ammonia. There's 2 things that can go wrong. Here I've got a precipitate, it looks okay. I'm going to centrifuge it. Pull it off. I can handle the test tube with my fingers now because I've been dripping out everywhere all day today. Today I finally didn't drip anything. So sometimes things work better than they do other times. And I don't put these caps out in the lab because they're too easy to get lost. But when I put the reagents away for the evening, I put the caps on back there. See the nitric acid start eating up that paper. Okay, let's see if I got a white precipitate. What did I do with it? I lost it. Oh, I put it in the centrifuge. I was ahead of myself. I'm getting ready to centrifuge it. I don't know why I didn't turn it on. Okay, so anyhow, it looks like there's a white precipitate. This is procedure 4B. And I used S, the solution from procedure 4A. And I added nitric acid. I guess everything really vibrates here. And now I'll look and see if I have a precipitate. Yep, I've got a white precipitate. That's the first thing I can say. I have a white precipitate. But the other thing, I should check for completeness. Because I don't know if I had enough acid. One of the things it says you can do, if you don't get a precipitate and you've added some more nitric acid, you should check with litmus. One of the things we'll have on that cart is little vials of red and blue litmus. And everybody says, what color is what? And I said, remember when you did it last semester in 1A? And everybody says, no. And I said, well, the way you find out, you take a piece of red litmus, you take a piece of blue litmus. We have bottles back there that say acid and base. You touch a drop of acid to each of the colors of litmus, and then you touch a drop of the base to each of the colors of litmus. You see which one changes, and now you'll never forget because you learned it for yourself instead of asking me every lab period. Okay? Sometimes I'll tell you if I'm in a hurry. Most of the time I'm going to make you find out for yourself. Okay? So, if I wanted to test for acid, I would use the blue paper, would turn red. Test for acid, I'm just going to add an extra drop of acid. Well, my acid is dripping all over the place. What's happening here? That's why the label, that's another reason the labels don't last too long. Okay, I was going to do one more drop of acid to check the completeness. I'm pretty sure it's complete. Go ahead. First time it went so well, notice I didn't use my eye drop with my test tube holder, but fortunately I didn't drip any on my fingers either. And I'm not getting any more precipitate as the acid went into the top, so that's complete. So that's my white precipitate. Solution is colorless. That's an irrelevant piece of information at this point because there's nothing more to be done. I've got the white precipitate. I did have silver present. I have a little sample. I want to look at the mercury. This is just a little small for a medium, so somehow I didn't get all my mercury. I lost a little bit somewhere. But twice that would be a medium. But notice a factor of 2, that's no different. In other words, twice as big as this or half as big, it's still a medium. If it's 10 times smaller, then it would be a trace. So factors of 2 aren't that bad, but this is just a little bit smaller than I would expect. Not enough that I would say it's not a medium, but I would like a little bit more. So when I say sometimes it could be twice as big, it doesn't mean it's bad or anything, it just means it's not quite what the perfect sample should be. And that's how I will rate it down. Okay? Any questions? So on Monday, or not Monday, you can do it on Monday, you can start preparing your lab notebook. The first thing you do